In the name of Almighty Allah, the most gracious, the most merciful. As Muhammad, peace be upon him, narrated, if anyone travels on a road in search of knowledge, Almighty Allah will cause him to travel on one of the roads of paradise. Hello everyone, this is Dr. Tariq Masood. Thank you very much for watching my videos and your wonderful support to make this channel a grand success. We are a family, a partner. Please share and subscribe our channel if you haven't done so far. We as a team can work together to convert challenges into opportunities and opportunities into success stories. These success stories can be monetized into value addition in the world by large. Thank you very much for your precious time. Okay, today I'm going to discuss my lecture number 22, oil and gas production, exploration, production, upstream, midstream, refining, petrochemical, differentiated performance, enabling profit optimization, lecture number 22. Before my lecture, I used to read a Quranic verse. Qala Rabbi shrah li sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli Allahumma Rabbi zidni ilma. O my Lord, open my chest and ease my task for me, and loose a knot from my tongue that they may understand my sins. Allahumma Rabbi zidni ilma. O Allah, advance me in my knowledge and a true understanding. Okay. So, oil and gas production, introductions, facilities, processes, reservoir and wellhead, upstream facilities, midstream facilities, refining facilities, petrochemicals, utility systems, unconventional, conventional resources, and environment effects. What is the ultimate goal? Shaping the clean and sustainable global energy delivery. Plan to deliver more than 300 lectures in the next couple of years. Okay, oil and gas production, downstream facilities, lecture number 22, refining, we are going to discuss today. So for my next slide, I will give you key takeaway points from lecture number 22. Key takeaway points, lecture number 22. Today we are going to discuss refining process, frictional distillations, naphtha, gasoline, kerosene, and diesel oil. Okay, refining description. Up to the early 1970s, crude oil prices were kept reasonably stable by major international oil companies and industrialized nations. Less value was created in the upstream production operation, and relatively more profits were generated in refining and distribution operations. Within 1973, oil crisis and rising crude oil prices, more of the value was created upstream. Now, the success of the modern refinery depends upon economies of scale and the ability to process a wide range of crude into the maximum quantity of the high-value fuels and feedstock. A refinery that is able to handle multiple types from heavy to light crude is said to have a large swing. Okay, trade specifications such as West Texas Intermediate, WTI API 38.3, Brent a blend API 38.3, Heavy Arab crude API 27.7 or Gran API 18.7 are example of the such crudes. Medium light crudes can be used directly in early engines and burners. Modern consumers such as gas and diesel engines, aviation, turbojets engines, and ship bunkers need a fuel manufacturer to precise a specification. This includes removing contaminants and pollutants particles such as sulfur or H2S. Okay. Okay. Frictional distillation. The basic refinery uses frictional distillation. Incoming crude is heated to its boiling point. It then enters the distillation column, which separates the different frictions. The column is of the reflux type, where a colder condensed fluid running down or reheated by rising vapor that is in turn condensed. This produces a clear thermal zone where the different products can be drained. Okay, as per the schematic, if you can see here, and we will just discuss each segment in my next slide. Both continuous or vacuum distillation is used in separate vacuum to avoid heating the raw crude to more than 370 degrees Celsius. Overheating would cause thermal cracking and excessive coke that may also plug pipes and vessels. Also, a side cut stripper is used in addition to the main column to further improve separation process. Side cut is another name for the frictions emerging from the side rather than a top and bottom of the main column. Okay, naphtha, gasoline, kerosene, and diesel. The frictions are mix of alkenes and aromatics and other hydrocarbon, so there is not a linear and uniform rising relationship between carbon numbers, means that each friction contains a distribution of a carbon number and hydrocarbon. Okay, basic products of the frictional distillation column. Okay, if you can see here, the first is LPG, domestic gas petrochemical feedstock, that is draw at 20 degrees C, C1 to C4 gas. Number second is petrochemical products, naphtha. Okay, it contains a C1 to C9 at 70 degrees Celsius. And a third, a car gasolines, C5 to C10. So it draw at 120 degrees Celsius. Okay, so the jet fuels here, so C10 to C16 kerosenes, 170 degree. And next is a diesel fuels, C14 to C20, so 270 degrees Celsius. Okay, so then lubricant wax polish, C20 to C50 lubricants. And then over here is the bunkers fuels, a boiler district heatings, 600 Celsius, a C20 to C70 heavy oil. And last here, asphaltene, which is used as C70 and above, wetman asphalt for the construction purpose, roads and other purposes. Okay, frictional distillation, continuous distillation process. Okay, first we are going to discuss liquid petroleum gas LPG. Has a carbon number of 1 to 5 and boiling point up to 20 degrees C. Most of the LPG are propane and butane with carbon numbers 3 to 4 and boiling points minus 42 degrees C to minus 1 degree C respectively. Typical usage domestic and camping gas, LPG vehicles and petrochemical feedstock. Second is a naphtha. Naphtha or full range naphtha is the frictions with a boiling points between 30 degrees C to 200 degrees C and molecules are generally having a carbon number 5 to 12. The friction is a typical 15 to 30 degree. The 15 to 30% of the crude oil by weight. It is used mainly as a feedstock for other processes as well. Refinery producing additive for high octane gasolines. Number 2, it's diluent for the transport of very heavy crude. Feedstock to the petrochemicals, olefins chain, feedstock for many other chemicals as a solvent in cleaning purposes. Okay, next is a gasoline. Okay, gasoline has a carbon number mainly between 4 to 12 and boiling points up to 120 degrees C. Its main use is as a fuel for internal combustion engines. Early on, these frictions could be sold directly as a gasoline for cars, but today engines require a more precise formulated fuel, so less than 20% of gasoline at the pump is to a raw gasoline frictions. Additional sources are needed to meet the demand and additives are required to control such parameter as octane rating and volatility. Also, other sources such as bioethanol may be added up to 5%. Okay, kerosene. Okay, kerosene has a main carbon numbers 10 to 16, arrange 16 to 16. Of boiling a point 150 degrees C and 270 degrees C, its main uses as aviation fuel, where the best known blend is jet A1. Kerosene is also used for lighting, paraffin, lamps, and heating purposes. Okay. So the next is the diesel oil. Petrol diesel is used for a diesel engine in cars, trucks, ships, trains, and utility machines. It has a carbon number range from 8 to 21, mainly 16 to 20, and is the friction that boils between 200 degrees C to 350 C. Okay, then white and black oils. Okay, white and black oils, the above, as we discussed, the oil and the frictions are generally available from the atmosphere distillation column. The remaining frictions or the black oils, which must be further separated by vacuum distillation due to the temperature restriction of heating raw crude to no more than 370 to 380 degrees C. This allows the lighter fractions to boil off at the lower temperature than with atmosphere distillation avoid overheating. Okay, lubricating oil or mineral-based lubricant oil, as opposed to a synthetic lubricant, form the basis for the lubrication wax and polishes. These typically contains a 90% raw material with carbon numbers from 20 to 50 and are friction boiling at 300 to 600 degrees Celsius. 10% additive are used to control a lubricant property such as viscosity. Okay, next is the fuel oil. Fuel oil is a common term encompasses a wide range of fuel that also includes a form of kerosene and a diesel, as well as the heavy oils bunker that is produced at the low end of the column before bitumen and coke residues. Fuel oil is graded on a scale of 1 to 6, where the grade 1 to 2 is similar to kerosene and diesel. 3 is rarely used anymore. 4 to 6 are the heavy fuels, also called a bunker A, B, C, where the B and C are very high viscosity and 120 degrees respectively before it flows enough to be used in engine or burner. Fuel oil grade 4 does not require a preheating and sometimes are mixed with off-spec products such as tank residue and interface liquid from multi-phase pipeline, or with grade 2 fuel oil to achieve a low enough viscosity at ambient temperature. Fuel oil 6 is the lowest grade. Its specification also allows 2% water, 2% water and 0.5% of mineral salts, and is consumed almost exclusively by large ships in international water where the pollutant such as sulfur is less regulated. Okay, last is bitumens or asphaltene, and other residue like coke and tar has carbon numbers above 70 and boiling points above 525 degrees C. Low sulfur coke can be used for inodes in the metal industry, aluminium and steel. After processing cleansings, the remainder is a problem of fuel because of high sulfur content and even higher CO2 emissions than a coal, typical 15% higher. Bitumen in the form of asphalt boiling above 525 degrees C is used for roofing and road paving purposes. Asphalt concrete paving materials commonly composed of 5% asphaltene and 95% stone, sand and gravel, etc. Thank you very much. It was my last slide. From next slide, we will conclude and wind up our today lecture. Okay, today we have discussed a refining process, frictional distillations, basic products, LPG, fuel gas, gasolines, kerosenes, diesel oil, and a black and oil, white oil. Okay, my next topic, oil and gas, be refining facilities, lecture number 23. Okay, references: Qatar Petroleum, Doha, Qatar, Oil and Gas Development Corporation, OGDC, Pakistan. World Energy Outlook 2013, US Geological Survey, US Department of Energy, Schlumberger Oil Field Glossary, International Energy Agency, Wikipedia, Oklahoma, State Oil, North 6, Standard, Norway, Story of Oil in Pennsylvania, A Liquid Gas Encyclopedia, Natural Gas from Wellhead to Burner Tape. Okay, together, everyone achieve more. Please do not hesitate. Send me your feedback and comments. t.masood.dr@both.edu. I have also provided my WhatsApp number. You can also send me WhatsApp. Thank you very much for your precious time. Please stay at home, stay safe, inspired, and blessed.